Okay, we're going to number 27. 27, we have synchronous communication satellites are placed in a circular orbit that is 3.59 times 10 to the 7 meters above the surface of the Earth. What is the magnitude of acceleration due to gravity of this distance? So they're talking about a synchronized satellite. First of all, you might need a few constants. Some of the constants that kind of show up a lot are the mass of the Earth, which is 5.98 times 10 to the 24 kilograms, and the radius of the Earth, which is 6.37 times 10 to the 6 meters. Using the radius of the Earth, we can find the actual r. We're going to use an equation. R is the distance of the satellite from the center of the Earth. So r is the radius of the Earth plus the distance above the surface of the Earth. So then our actual r we're going to use is 4.227 times 10 to the 7th meters. There's at least two different ways you can solve for this. One way to solve for this is you need to know that the period, is 24 hours. Synchronous communication satellite means that it makes one complete revolution at the same time the Earth does, so they follow a 24-hour cycle. The next thing you can do is you can find the velocity of the satellite. The velocity of the satellite you can simply find by taking the circumference, which is the distance traveled in one period. T is the amount of time for one period to occur. So it's simply 2 pi times the radius we calculated divided by the 86,400 seconds, and we get 3,073.96 meters per second. Quick note, all geosynchronized objects around the Earth have the same velocity, the same period, and the same radius. Every time they shoot up a satellite up in space that has to be in synchronized orbit, it has to be pretty much 3.59 times 10 to the 7 meters above the surface of the Earth. It has to be traveling at about 3,073.96 meters per second, and of course the period has to be 86,400 seconds. In case you have a question like that. It's a little off depending on how you round, because you can round with the radius and everything else, so you might see a different answer in different books, but for the most part it stays close to the same numbers. Now, another relationship you can use, I know that when things are in orbit, their centripetal acceleration of the circular object is equal to the acceleration due to gravity. So we can use that relationship, and I know centripetal acceleration is v squared over r, so that means the little g is the velocity squared divided by the distance from the center of its orbit. So we find out that the acceleration due to gravity is 0.223 or 2.23 times 10 to the negative 1 meters per second squared. The other way we could have done it, the shorter way, which might be the way they wanted you to do it, is using the equation that little g is equal to big G times the mass of the object creating the acceleration due to gravity over r squared. And for that, we just plug in our values, our mass of the Earth, our constant g, and the radius we calculated early, and then again we get the same answer, 2.23 times 10 to the negative 1 meters per second squared. And that's pretty much it.